Whether focusing on an individual school or across an entire district, getting the community's perspectives on how well educational best practices are being implemented is an essential requirement for leadership. That kind of perceptual data can be instrumental in helping to shape a school or district improvement plan. To make the most informed decisions about curriculum, instruction, and students, teachers need to work with information resources. But all too often, that means working with static, ineffective paper resources that present only a limited perspective of a complex reality. A far more productive alternative is to work with a visual analytic resource, an analysis environment where the educator can create meaningful displays of data for generating important knowledge for decision making. This is MVAR, and an example of an Excel-based visual analytic resource built to work with Massachusetts standardized test data. This MVAR was designed for a middle school and begins with a 5-year overview of school performance in English language arts and mathematics. In a single visual display, educators can get an overall sense of strengths, needs, and trends over time with respect to the school, individual grade levels, major content areas, and student subgroups. Much of the display's meaning is derived through the use of color, which is user-driven. We'll see how that is done in a moment. Clicking on a second global display adds specific data points, in this case, the average percentage correct for each strand and topic area. The school profile page is the heart of the MVAR resource, where a variety of data is displayed in a variety of visual formats, all within the user's immediate view. In a visual analysis resource, the user can set all manner of analysis parameters to change the visual display of the data. For example, in this display, we're looking at the performance of all 6th grade students from the 2013 test administration. The aggregate display we just left suggested that low-income students in 6th grade were having some difficulty in mathematics. By clicking on the subgroup cell, the user can select from a list of possible subgroups, such as the low-income group. And now we have a different display, one that tells a very different kind of story. We mentioned that color is used to suggest levels of performance. In this case, the cutoff values for strength, need, and critical weakness are based on school-determined values. What if instead of using internally selected values, the school wished to compare the performance of its 6th grade low-income group with the average performance of 6th grade low-income students from the rest of the state? This would require a different color system, which the VAR can provide us. Here we switch from a school-determined coloring system to one based on school-state comparisons. Note how the user's decision to change the system of color designations to a school-state comparison immediately presents a far different and much improved story for this school's 6th grade low-income students. This was done with a single click of the mouse. How long would it have taken to glean the same information using 1,000 pages of color-free paper? Sometimes seeing multiple displays on one page can help capture a larger story, such as this story of progress over time for the 2011 6th grade cohort as they move through 7th and then finally 8th grade. While seeing global and large-scale views of data can be helpful to understand the big picture, teachers often need to drill into the data to discover stories with greater detail. MVAR provides 2 displays that get down to the question level for the ELA and math tests over the past 5 years. Each dot on the chart represents a question on the math test for a selected group of students in a particular year. This example shows all 8th grade students for 2013. What about our 6th grade low-income cohort? A quick selection change, and the visual analytic resource provides the user with a new story. Remember that comparing performance to state averages was an important analysis task for this school. Note how the user can instantly bring up state data at the question level for comparing the school's 6th grade low-income students to the state's averages for the same cohort. With the visual analytic resource tools of the plot sheet display, the user has the ability to change multiple analysis parameters to drive collaborative conversations with fellow educators. As educators come to grips with the need to use all manner of information resources as effectively as possible, they are faced with a very important question. Spend hours and hours poring through static mounds of paper? Or engage with powerful visual analytic resources that will change the very nature of collaborative analysis for K-12 educators?